Hello, everyone. I hope you can hear us. We're just about to start our Tech Talk, our first ever Jakarta Tech Talk. So let me first introduce myself. So my name is Tanya Obradovic, and I got this fabulous opportunity to be your Jakarta EE program manager. So today we're starting with our new series, and we're hoping to discuss topics related to not just Jakarta EE, but Java Cloud Native topics as well. And we are starting with the first Tech Talk from Otavio, who is right here as well. So Otavio will be talking about the Jakarta meets NoSQL, the specification that is going to be under Jakarta EE. And then we'll listen Wayne Beaton, who is going to talk a little bit about the process and what we can do to start things off. And then we'll open the session for questions and answers. So with this little intro, I don't want to waste too much time, and I will just hand it over to Otavio. And Otavio, you can take it from here and tell us all about Jakarta NoSQL.
Okay, thank you. I'm glad to be here twice. The first one because I'm gonna be the first guy to do the Jakarta series, and I'm gonna lead the first specification in Jakarta EE, right? So I'm gonna talk about Jakarta meets NoSQL because NoSQL gonna be the first specification in the Jakarta world. So my name is Otavio Santana. Let's share my screen. 1 second. So Tanya, can you see my screen? Does everybody can see my screen? Let's see. Okay, you can see my screen right now. So I'm gonna talk about it. So my Twitter handle is Otavio Java. So I'm a Twitter fan. Please follow me, and I can introduce some news about the new specification about the NoSQL products. So let me introduce you. So the whole idea here is talk about a Jakarta NoSQL specification. But first, I need to talk about what NoSQL is. So NoSQL is a different kind of persistence technology. Yes, that's a database. So you can put information there. We can retry information for there, update and delete information. But they don't use structure. They usually don't have transaction. And we have here 5 different types of NoSQL database. The first one is key value. So we have several implementation of this kind. It looks like a key hash map or map implementation from the Java world. So given key, I can retrieve some information from this key. For example, I have the Apollo that returns the sun, Aries, the war. So given key, I can return the value. The next one is the column family. So here we have the structure that looks like a key value. However, it stores the value on different way. Each information gonna be stored in a column. As you can see here, for example, Aphrodite, it has a column that has the information lovey and happy, and color that has the pink information. So we have, again, we have several implementation. I believe the most popular one is Apache Cassandra, but you have 8Base, SquillaDB as well. Going to the third NoSQL database type, we have the document. The structure looks like XML or JSON5. We have several implementation. The MongoDB is so far the most popular NoSQL database famous around the world. So if you hear about MongoDB, yes, that's a NoSQL database of the type document. And we have also the graph. The graph keeps the relationship between the vertex. As you can see here, we have Apollo, Ares, and Kratos, and we keep the relationship between this guy here. Okay, what the difference between this technology and SQL technology? It's because I put the direction here. For example, I can say Kratos killed Apollo. And I can say again, Apollo was killed by Kratos. So I have direction to my relationship here. And the last one is a moot model. Basically, a moot model is when one NoSQL implementer implements more than one type. For example, I have OrangeDB that implements two different types, so graph and document. So that's a moot model. Okay. Usually, when you talk about NoSQL, you think about SQL technology. So here's the difference. We don't have enough time to talk about the main difference. What I'd like to show here is the structure matters, and each NoSQL type has a different structure in a different hierarchy. For example, SQL has relationship, and key value and the column don't have relationship. And graph, I have an entire object to hold the relationship, and also the direction, the properties. So I can go deep on relationship with graph, deeper than SQL and relational technology. And okay, let's talk about the application, the Java application using both persistent technology. On this hand here, I have the relational application that I have my logic application, and then I have my DAO, data access object. If I'm using the standards, I have the JPA and the JDBC. So JPA is the mapping layer, so I have my objects and put some annotation, and the JDBC does the log communication. So basically, it's gonna use SQL, gonna communicate directly to the database. On the other hand, I have the NoSQL application. So the difference here is because I don't have a standard yet. So I have one API to different kind of NoSQL database. That means if I'd like to change, I need to learn a new API. I need to change my whole API application. And the first solution that people is looking for is why I don't use JPA to solve NoSQL issues. The first reason is because JPA was created to SQL technology. So the API did not cover something like saves asynchronously, the time to leave definition, the constants level. And one important thing here on NoSQL database is because the diversity matter to NoSQL words. So we have Cassandra that has specific behavior that I'd like to use. And to look to have the solution, we have created the Eclipse NoSQL solution that look like the JPA JDBC solution, and they have a small difference because we have the mapping, we have the communication, and we have to each NoSQL type on different API. So one API to column, one API to document, one API to key, and one API to graph database. Okay, so why we have two different APIs? We have API to communication and one API to mapping. As you can see here, we are looking for the communication native API. We have the ArmongDB, we have MongoDB, we have Couchbase, and ArrayDB. All these guys here are NoSQL database, and also our document NoSQL database. And as you can see here, the class are different, the method name is different, but they try to do the exactly same thing. Give the document, try to put information there, name and value. Why not just use one interface and each provider implements of this way? That's what you're looking for. And again, the diversity matters. So we can see here some interface that has multiple implementation, and also we have something that belongs just to Cassandra as the CQL, because CQL means Cassandra Query Language. And the last line here is a consistency level that just belongs to Cassandra. And okay, you talk about the communication layer, so let's talk about the mapping. The mapping looks like the JPA. So we have some annotations such as entity, column, ID, and something like that. And we have some specific communication to this mapping layer. So for example, here we have the document templates that is to connect to document type. And one that intensive thing here is that we have the repository concept. So basically, we have the interface. We create the interface. We extend the repository interface, and done. The framework gonna implement everything to you. For example, here, by convention, so I create the method find by name, and that repository from God. So it's gonna find by name. It returns just one God with optional. Also, I can use find by name and age ordered by something. So we use the convention. We can do some queries. And again, at the communication layer, the mapping matters, the diversity matters. So we have something like UDT annotation that's a user-defined type that belongs just to Cassandra NoSQL database, as the CQL annotation that run CQL and then convert to God entity. And one cool feature is we have the queries by text. So as you can see here, I have the document template that does operation to document. I have the column template that does column and that does column operation, key value, and graph. As you can see here, the query are different because the structure are different. So, and then we have prepare statement. We have something like we usually do on SQL technology, use on NoSQL words. Okay, and of course, given repository can use some query annotation and use some parameters, and they're gonna implement automatically to us. So I believe I have time to show a demo. Okay, let's share a different screen. That's this guy here. Okay, here is my sample. I have an entity that's a God entity. So that has some annotation, as you can see here. So I have the God. I have some ID annotation to say, okay, this attribute, this field here is ID. I have the column, and that's a Java object, right? So I have my builder here, that's God builder. So, and I have a simplest way to start my NoSQL database is using Docker Compose. As you can see here, I have Redis, Cassandra, Mongo, MongoDB, Neo4j, and have a JSON file that has our configuration that JNoSQL needs. So as you can see here, it's a JSON file. So the first one here belongs to key value. The second one belongs to the column that are using Cassandra. The third one is to document that you are using Countbase. And the last one is a graph database that are using Neo4j. We have the God repository. As you can see here, there's no implementation to this guy. The whole idea here is to the NoSQL implement it automatically to me. Okay, I have the whole sample here gonna be on the GitHub, so you can study, you can go to get more information about it. I'm gonna pick one to run some demo. As you can see here, it's a CDI 2.0, so I start a container using the Java SC, and then I inject my repository, I create my entity, and then use save, and that is it. I can find by ID. As I told you, I can create my home convention here. So find by name, I can find object by the name. There's something here happened with the sample here, this time with the document. So the whole idea is I start the container, have my template, and in this template here can do some operation, can make some operation to us on an easy way. Of course, we have a query. As you can see here, what I'm doing is starting import, and we are using here Fluent API. So select here all the fields from God where the name is equal Diana. And then I have my query to document operation, and then I can retrieve this guy here. Okay. I can also define the TTL. So remember, the whole idea here is to define the time to the entity lives on the database. So as you can see here, the duration is for 1 second. So if you're gonna zip for 2 seconds, when I return again, it's gonna return empty. The key value, of course, this one is smooth, because key value, basically I can retrieve just for the key. So I create my entity, Diana. I return it from the key Diana. I can define the time to leave. Again, use my key. My key is totally mandatory here. Remember, key value is look like the map from Java. And the last one that I'd like to show more is my graph database. I believe the graph database is more different one if you look for SQL technology. So I have my graph template, again, to operation to graph. And then I create two two entities, Diana and Apollo. I insert it in the database. I use some transaction to say, okay, it's time to go to the database. And then I do a query. As you can see, this one is totally different from document. So give my vertex that has God label and has the name Diana. And done. It's returned Diana and then Apollo. And then I create a relationship between this guy here. So if Diana, I can say Diana is brother of Apollo, and Apollo is also brother from Diana. Why this? Why this both relationship? Because again, graph has directions, and I can do more queries, as you can see here. Give my vertex that has Scott as label, that has the Diana name, and then you can return from family. So give a God that has a broader relationship, and I'd like to return both. So that's the result. So let's start the Docker here. 1 second with this graph database. And okay, it's up. It's a Docker. So let's run this guy here. Let's run. I'm gonna stop show this screen here, and then I'm gonna show the Neo4J Console. This little guy here, as you can see. I can do some operation, but for now, as you can see, I have Diana, that is brother from Apollo, and Apollo that's brother from Diana. Usually, recommendation engine use graph database a lot, mostly Neo4j. And as you can see, my whole code, I'm using, let's show my code again. I use a common API. So I have my communication layer here that is Redis to key value, Cassandra to column, count-based document. And I can change that. So, okay, I'd like to use column, but 8 base. I just need to change that dependence to an 8 base driver. Or I'd like to use Hazelcast instead the Redis. So I just replace this dependence here to, okay, this time I'm going to use Hazelcast instead of Redis. Okay, let's return to the slides. The slides here. And as we did that presentation. Right now we have some providers, some NoSQL providers that Eclipse and NoSQL offer to, if you'd like to use. So we have support Cassandra, Schilla, Elasticsearch, RMDB, RNDB. And one part of here is Jakarta NoSQL. Gonna use Eclipse NoSQL as reference implementation. Okay. That is my presentation. Wayne. That's all. Is there any question? I believe Wayne is gonna be first, right?
Yeah, I'm ready to take over. But Stephanie and Tanya, do we need to any business before I do that?
So you were what was your question, Wayne? I'm sorry.
Pardon me. I'm just ready to take over. I was
Yep, you can take over.
All right. Okay, here we go. I am screen sharing. So can I safely assume, Ottavio, can you nod your head that you see a slide that says Eclipse Foundation specification process?
Yeah.
I can see it. Thanks.
Okay, excellent. Okay, good. So I only have a couple of minutes. I plan to speak only for 10, and I might come a little shorter than that. I just wanted to talk a little bit about where we are in the process and sort of make sure that we as a community are on the same page or thinking the same sort of thing about what's next. So just to refresh everybody's memories, our goals with this effort are first to push out Eclipse Glassfish 5.1. Now, Eclipse Glassfish 5.1 is implementing the existing Java EE 8 specifications, and that's due out next week. And it looks like we're on track for a release of that, and that's frankly represents a huge amount of work from all sorts of people, and that's a wonderful thing in my mind. Certainly, though, there has been. We've allowed a few invalid, what I tend to refer as invalid intermediate states through this implementation. So the part of what we need to do following this is to clean up a couple of things, but by and large, this has been a great effort, and looking forward to rolling up our sleeves and continuing. The next stage, actually, the next stage is actually pushing out something, the Jakarta EE 8 specifications themselves. So, like I said, the work that we've been doing, we've done so far on Glassfish has been about moving the existing content over to the Eclipse Foundation to get us into a position where we can move forward. So with Jakarta EE 8 now, it's a matter of actually implementing our specification process, taking the existing specification content that we have and actually turning them into real Jakarta branded specifications. And that's going to be an interesting bit of work as well. Once we get to that point and we declare success on the Jakarta EE 8, then we're looking at the really exciting part of this, which is the opening up the floodgates and allowing real interesting new development work to go on. One of the things we're trying to do, and I hope that the community appreciates this, is we're trying to keep Jakarta EE 8 will be offer functional parity with Java EE 8. We're trying to minimize the amount of change that occurs in the code bases and in the specification documents themselves. This should result in what we're looking for would probably be minor modifications of source files, the comments, that sort of thing. No changes in method signatures, changes of specification names, possibly, that sort of thing. I just wanted to talk a little bit about what specification projects themselves will look like. The little bit different than what we used to do with the JCP. As I look through the various JSRs, I see multiple JSRs, different compositions of teams, and whatnot for the various specifications as they evolve. With the Eclipse Foundation specification process, we have one persistent project that is responsible for creating one or more specifications. The project has a team of committers, and like any other open source project at the Eclipse Foundation, committers are added to the roles, removed from the roles. There's a natural way that that teams change over time. But the fact is that there will be a single team that moves forward multiple versions of any particular specification. Now, I did say that a specification project may handle multiple specifications. We actually have a project. It's called Eclipse Project for Stable Jakarta EE APIs. And this project actually holds 5 specifications right now, or is intended to hold 5 specifications. The idea being that as specifications become more stable, and there are not a lot of potential for innovation, and we decide that it's not something that's going to grow significantly, we can aggregate projects into or aggregate specifications into this project or into others. So, very much a maintenance style project. And there's a couple of other cases where a single specification project may hold multiple specifications. I thought I'd talk a little bit about when we use the word specification. Specification is one of those words that we tend to overload. We refer to in the specification process a specification document. Again, very often people will use, when they say the word specification, they mean the specification document. We think of the specification being the entirety of the artifacts that make up a particular specification, and in fact, I'm actually calling out a specific version of a specification with this diagram. This particular version of a specification will have a document. It will have certain technical artifacts in the Java space. This manifests as API files, interfaces, that sort of thing. A specification version also has a TCK and pointers to one or more compatible implementations. Now, this is another place where we differ from the JCP. We don't have a notion of a single reference implementation. Instead, we have a notion of compatible implementations. And one of the requirements for a specification is that there must be at least one compatible implementation using an open source license. The list of open source licenses is currently, and I'm going to flip over to make sure I get this right, the Eclipse public license, the Eclipse distribution license, which is a BSD3 clause, or the Apache license version 2. So again, to be a specification, according to our process, there must be a compatible implementation under one of those open source licenses. Now, that's not to say there can't be implementations under other licenses, and certainly an implementation that conforms to the specification would be said to be compatible independent of its license. The notion here, though, is that in order for a specification to be valid, there must be at least one compatible implementation under one of those licenses. I'm hoping that's not made things more confusing. So we combine these various artifacts into, like I said, a particular version of a specification. The collection of artifacts is something that is distributed as a unit and is thought to be indivisible for any particular version. There's no rule that suggests that the TCK be represented in any particular project. So what we're seeing right now, for example, is we have a single TCK project that covers most of our specifications in the Jakarta space, and that's fine. It's actually part of like I said, part of a different project. Thought I'd talk just briefly about the process over the day-to-day work of the committers, and I've highlighted the creation review part here because for specification projects we're actually kind of at that stage right now. Strictly speaking, we have a bunch of regular old Eclipse open source projects right now that contain some specification content, and part of our process to engage in the specification development work will be to convert these into specification projects. I did actually a quick look, and it's looking like a lot of the specification projects, these are all the ones called Eclipse Project for something. A lot of the project teams have reworked their scopes, which is pretty cool. So we've actually got some fairly well-defined scopes on these projects. So we're gonna, at some point we need to move these projects forward and turn them into specification projects so that we can do the actual specification work. Part of that is getting the scope right. Part of that is we're going to require that the committers need to provide us with a little bit of new paperwork, some more paperwork, and then again we'll move forward into a development phase. The reviews through this process all require approval from the specification committee of a working group. This is a committee that's basically put together to provide some governance and oversight of the specification process, specifically for the Jakarta projects. And so it's part of that we get their approval on the creation review and the progress review. Much like with the JCP executive committee, the way that the specification committee votes, the criteria that they follow is what we're looking for is that they're ensuring that projects are staying within scope and that they're operating sort of with good intentions in the specification process. And with each review, the specification committee just gets an opportunity to ensure that this is true. So the specification committee gets a chance to weigh in on a plan for new development. They get an opportunity to approve the progress of a project. And then ultimately, when a project engages in a standard release review per the Eclipse development process, the specification committee gets a vote as well. The specification itself goes through a transformation after a release review to become ratified, kind of marking the specification official. And it's at that point when a specification is ratified that implementers can claim compatibility with the specification. Anyway, this really all I intended to speak about today. Just a little brief overview, remind people what we're doing and where we are in the process. And with that, I'm happy to answer any questions. You can also send me questions directly to my email, wayne@eclipse.org.
Okay, thanks, Wayne. Thanks, Ottavio. So we'll open this for additional questions. I do see some questions in the chat as well. And I also see we have answered quite a few. So if there is something else, do let us know. And we will, have these sessions once a month. And we'll give you plenty of opportunity to ask us questions. I also want to mention that next week we have a Jakarta EE town hall, and I hope you all got the notification about that. So feel free to join that session also, and then you will have the opportunity to kind of ask questions from various members of the working group on the status of Jakarta EE and where we're going, what has been done, and so on. So with that, are there any questions that still need answering? So can you tweet the link to the Jakarta EE town hall? Absolutely. I don't think there is going to be a live stream, but there is a session and a link that we're providing to Zoom where you would be able to join. So it is. We also have the Meetup organized, and the Meetup is going to point you to the Zoom link. So hang in there for that. Wayne, do you see, or Ottavio, any additional questions that you would like to answer? I see your question on the licenses. I think Wayne mentioned all the licenses that are related. Hold on. Your demo project available somewhere. Ottavio, I think that question is for you.
Yeah, let's share the screen, the link. Okay, I put there as the answer.
Okay. Sounds great. So where I can find the code at GitHub. So if you go to Jakarta EE, .ee link, you will find the pointers from there. If you don't find it, please contact us in a different way, and I will send you the direct link. Yeah, you can also, please don't forget from the Jakarta Tech Talks, where you joined this session, to subscribe to all the, or look at the pointers to Get Social, right? And subscribe to the YouTube channel, to Twitter, Facebook, LinkedIn, and do help us out to promote Jakarta EE. We also absolutely love to see more members of the Tech Talk meetups, Jakarta Tech Talk meetup. So please join the meetup and help us out. So with all of this, thank you very, very much for joining our first session. And you're more than welcome to join us for the Tech Talk next week with Zoom. And then, of course, in February, we're looking forward to see you again. Thank you so very much. And I will stop the broadcast right now, and we'll talk later. Bye.